All right, today we're talking partial quotients division. I've got the same problem written up twice on the board. 1,493 divided by 6. I've got it written up here twice because there's more than one way to solve a partial quotients division problem. In fact, there's 3, 4, 5, maybe more than that ways to solve this particular problem using the partial quotients method. In this case, we're going to pretend that 1,493 are actually individual M&Ms. And we've got 6 friends that we want to share the M&Ms evenly among, if we can do it. We'll see if we can. We could hand out those individual M&Ms one at a time. We could say one for you, 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 one for me. But with 1,493 pieces, that would take a really long time. So could we hand out bigger chunks? When we think about handing out bigger piles of M&Ms, what would those piles be in? What would be useful groups to hand them out in? Well, we use friendly numbers. Friendly numbers are most often multiples of 100, multiples of 10, multiples of 5, or multiples of 2. Now, again, I could start off with making piles of 10 M&Ms, but that would still take me a while. I've got a lot of M&Ms here. So could I give out bigger piles, even bigger? Do I have enough to hand 100 M&Ms to each person? I do. So let's go ahead and start out there. If I hand out 100 M&Ms to each of those 6 people, how many total have I handed out? 100 times 6 is 600. Then I have to figure out how many M&Ms I have left over so I can start handing those out as well. Well, 3 minus 0 is 3, 9 minus 0 is 9, and 14 minus 6, that's going to give us 8. Wow, I still have 893 M&Ms to give out. Can I give out piles of 100 again? Do I have enough? I've got 6 people. I have enough. 100 times 6, again, is 600. How many left over? 3, 9, 8 minus 6 is 2. Now I've got 293 M&Ms. I don't have enough to give out hundreds anymore. So what friendly number could I use? Well, I could use 10, but giving out 10 would still take a while. Could I use a number bigger than 10, like a multiple of 10? Could I give out piles of 20 M&Ms at a time? How much would that equal? Let's see. 2 times 6 is 12. So if I gave each person 20, then 20 times 6, well, I've got the 2 times 6, which is 12, and then I've got to deal with the tens, so I add in that 0. That takes care of a big chunk, 120. Now, how many do I have left over to give out? 9 minus 2 is 7. 2 minus 1 is 1, 173. Can I give out piles of 20 again? Well, I already did it once, and it came out to 120, and 120 is less than 173. So yeah, I can. Three minus 0 is 3. 7 minus 2 is 5. I've got 53 M&Ms left. I don't have 120 anymore, so I can't give out piles of 20. So what could I give out next? Could I give out tens? Actually, that's really not going to work because 10 times 6 is 60, and I only have 53 left. So what I like to do is I think what times 6 will get me close to, without going over, 53. Well, I could use a friendly number like 5. That would certainly work. But I'm kind of running out of space here, so let me see if I can get it done in one step. Let's see. 5 times 6 is 30. So I need to go higher than that if I want to get close to 53. 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. And 6 times 9 is 54. 54 is too high, so I can't give out 9 to each of those 6 people, but I can give out 8. If I give out 8 to each of those 6 people, then I've given out a total of 48. And let's see how many I have left over. We can do regrouping if you want. 13 minus 8 is 5. I have 5 left over, and I can't share 5 evenly among 6 people. Now I've just got to figure out how many each person has. Well, they have 100 and another 100, so that's 200, plus 2 20s, which is going to be 40, plus 8. So that's going to be, running out of space here, 248 if I add them all up. I write my answer up here, 248, but my answer is incomplete because I still have those 5 left over that I couldn't give out. So that's going to be my remainder. So that's one way to do it. Here's another way. Watch and see if you can figure out what I'm doing. Right now I'm thinking, what times 6 will get me close to 29 without going over? I know 6 times 5 is 30, so that's too high. So what about 6 times 4? But again, I'm not trying to get to 29. I'm trying to get to 290. So I don't want to do 6 times 4, but I could do 6 times 40. 6 times 4 is 24, and then I've got that 0. How many left over? Well, let's see. 53 left over. And I already did my 6 facts over here, so I know 6 times 9 is too high, but 6 times 8 gets me right to where I want to be. If I give out 8 to each of those 6 people, 8 times 6 is 48. I can do some regrouping here. 13 minus 8 is 5. And now I've just got to add up how much I've given to everybody. First I gave them a pile of 200 M&Ms. Then I gave them each a pile of 40. And then I gave them a much smaller pile of 8. Altogether, that's 248 when I add them. So up here I want to write my answer, 248, but I've still got this to deal with. That's my leftovers. That's my remainder. So did I get the same answer? I did. 248 remainder 5, 248 remainder 5. In this case, I did it in 1, 2, 3 steps. Over here, I used more steps. 1, 2, 3, 4, 5. The number of steps you take to answer this problem doesn't really matter. I certainly could have done this in more steps. Instead of giving out piles of 20, I could have given out piles of 10. The idea is to use your understanding of the place value system, to use friendly numbers, to hand out big chunks of this number that you're dividing, and then figure out in the end what were the equal groups that you created. We created 6 equal groups of 248 M&Ms, and left over we had 5 as a remainder.